All right, welcome to The Explainer. Today, we are diving deep into the science of modern weight loss drugs. Seriously, we're going to take a journey right through the body, from the gut all the way up to the brain, to figure out how these things actually work.
But first things first, we need to ask a really basic question. Why is this even a challenge? Because, the answer isn't as simple as just have more willpower. It's way, way deeper than that. It's actually baked right into our biology.
So our bodies have this really complex, kind of beautiful system for managing energy. You've got energy coming in, energy going out, and energy being stored. And really, obesity is what happens when that whole system gets knocked off balance. So let's get into it.
Okay, here's the game plan. First, we'll cover the basics, how our bodies actually store energy. Then, we're going to look at three main strategies that these drugs use. We'll hit the gut, then the brain, and finally, the hormone system.
All right, before we jump into the fixes, we got to understand the problem, right? And I mean really understand it, like down at the cellular level. And it all boils down to one thing: energy.
So this is the textbook definition. But what does it actually mean? Well, think about it. When you take in more energy than you burn, your body's got to do something with the leftovers. It can't just disappear. So it packs it away as fat, these little molecules called triglycerides, and stuffs them into these specialized storage cells called adipocytes.
And this whole storage thing, it happens in two phases. First, your existing fat cells just get bigger. They puff up like balloons. That's called hypertrophy. But if there's still too much energy coming in, your body goes, okay, I need more storage space, and it actually builds brand new fat cells. That's hyperplasia. And this is the kicker. Once those new cells are made, they don't really go away. This whole two-step process is a huge reason why it's so biologically tough to manage significant weight gain.
Okay, so if the problem is too much energy getting in, then the most obvious place to start is at the front door, right? The gut. So let's look at our first strategy, which basically puts a bouncer at that door. The main drug here is called orlistat, and what's so different about it is that it's not messing with your brain chemistry or your overall metabolism. Nope, its entire job, its whole world is right there inside your gut.
So how does it actually pull this off? It's pretty mechanical, actually. See, in your gut, there's this enzyme called pancreatic lipase. Its job is to break down the fat you eat so your body can absorb it. Think of it like a pair of scissors cutting up big fat molecules. Well, orlistat comes in and basically gums up the scissors. It physically attaches to that enzyme so it can't do its job. The fat never gets broken down and it just passes right on through.
And the effect? It's pretty major. Orlistat can block about 30%, that's almost a third, of the fat in your meal from ever being absorbed. It just stops it cold. A completely physical block right there at the source.
All right, so blocking fat in the gut is strategy number one. What's next? Well, for strategy two, we're moving from the gut all the way up to headquarters, the body's command center, the brain. And we're zooming in on one specific area called the hypothalamus. This is basically the boss when it comes to your appetite.
This next strategy is all about, well, hacking your brain chemistry. And as you can see here, there are a few different ways to do it. These drugs target specific chemical messengers in the brain, your neurotransmitters, to do things like shut down your appetite, boost feelings of fullness, or even get rid of those nagging food cravings.
What's really fascinating about drugs like phentermine and phentermine is that they basically tap into our ancient survival instincts. They crank up a neurotransmitter called norepinephrine, which puts your body into a low-grade fight-or-flight mode. And when you're in that state, your body's natural response is, hey, this is not the time to be thinking about food. Plus, it also gets you to burn more energy. Now, this combo, naltrexone bupropion, this one is really clever. It's like a 1-2 punch. On one hand, you've got naltrexone, which works on the reward center of your brain. It basically makes food less rewarding. It takes away that, ooh, that was good feeling. Then, at the exact same time, you have bupropion working to just straight up reduce your hunger. So one part handles the craving and the other handles the physical hunger. Super smart. Okay, our last stop. And honestly, this is where things get really, really revolutionary. We're moving into the endocrine system. This is where the newest generation of drugs come in, and they work by copying, by mimicking the powerful hormones our own bodies use to send messages.
But before we can get how these new drugs work, you gotta understand the natural system they're tapping into. It's basically a 4-step domino effect. It starts with a signal from your fat cells, and it ends with your brain getting a message that says, hey, you can stop eating now. We're good.
Okay, but what if that pathway is broken? For people with certain rare genetic conditions, one of those dominoes is missing. The signal gets lost.
That's where a drug like setmelanotide comes in. It's designed to skip the broken parts and go right to the end, manually flipping that final I'm full switch itself.
And now, we've arrived at the ones you've probably heard about on the news, drugs like Ozempic or Wegovy. Their active ingredient is called semaglutide, and they belong to a class called GLP-1 agonists. Now, agonist just means mimic. These drugs are expert copycats of a natural hormone called GLP-1 that your gut releases when you eat. And the reason they're such a big deal is because they don't just do one thing, they do a bunch of things all at once. They slow down your stomach so you feel physically full. They send signals to your brain saying, yep, we're satisfied. And they help manage your blood sugar. It's not just one trick, it's a whole system approach.
This right here just shows you how fast this science is moving. We started out with drugs that could mimic one hormone, GLP-1, which was already a huge leap, but they didn't stop. Now we've got drugs like tirzepatide, which are dual agonists. That means they mimic two different hormones, GLP-1 and another one called GIP, at the same time. And when you do that, you get this amazing synergistic effect. The two together are way more powerful than either one alone. It's just a wild example of how quickly this field is exploding.
So, what's the big takeaway here? It's really about the journey we've just been on. Think about it. We went from a simple physical block in the gut to tweaking brain chemicals, and now all the way to precisely rewriting the body's own hormonal text messages. We are in a completely new era of medicine here.
Look, these breakthroughs are totally changing the game for how we think about and treat obesity. It's not just about weight anymore. It's about metabolic health. And it leaves us with a huge kind of mind-blowing question to think about. As we get better and better at editing our own biology, what's next? What does the next chapter of human health even look like?